quantum industry is going to need somewhere between 15 and 20,000 people who are experts in quantum error correction alone. Now, that's a nearly tenfold jump from today, and it's creating a talent gap of, well, historic proportions. If you want to be one of the people filling that gap, you are in exactly the right place. So let's really dig into this number for a second. This isn't just some vague, nice-to-have growth. We're talking about a projected 7 to 10 times explosion in demand for people who can tackle the single biggest roadblock in quantum computing, noise. And this massive chasm between the talent we have and the talent we desperately need, that's precisely where incredible careers are going to be made or completely left behind. And look, I'm talking directly to you. Maybe you're the physicist who's published some amazing papers, but you're just not sure how that translates into a real engineering role. Or you're the software engineer, you're a wizard with Python, but you feel totally lost in the language of quantum mechanics. Or hey, maybe you're the recent grad. You've done all the tutorials, you've watched all the videos, but the actual path to a real job feels like a total black box. You see the potential, but you're feeling the paralysis. And here's why you feel that way. The market is growing up. That initial massive wave of hype is finally pulling back, and now investors want to see real, tangible progress. And what that means for you is fewer of those vague, blue sky research jobs and a much, much higher bar for entry-level roles. The rules have changed, and honestly, the old career advice isn't just out of date, it's a trap. Now, before we go any deeper, I'm also going to show you how to apply everything we talk about today inside futurecareerplugin.online. It's an AI-powered career tool that's built for exactly this kind of situation. The link's in the description. Okay, here's what the research is really telling us, and here's my promise to you. By the end of this, you are going to have a solid, strategic framework to build your own personal action plan for a career in quantum tech. We're going to build this thing in 4 parts. First, we'll cut through all the noise and look at the hard reality of the quantum world in 2026. Second, we'll take apart exactly why that old career advice is setting people up to fail. Third, I'm going to give you a powerful strategic framework to map out your skills and find your unique spot. And finally, we are going to build your personal action plan step by step. So, let's get into it. Okay, Chapter 1, what is really going on in the quantum job market right now in 2026? Let's get real. So, if you zoom out, the big picture looks, well, absolutely astronomical. We're seeing projections from major players like IDC, McKinsey, and IBM Research that all point to a market rocketing from about $1 billion in 2026 to a mind-blowing $65 billion by 2030. This isn't some niche little industry anymore. This is the next fundamental layer of our global technology. The money's there, the strategic importance is there for sure. But that giant number kind of hides a much more complicated story down on the ground. And this is the contradiction that trips so many people up. On one side, you have this story of massive growth. But on the other, the reality for job seekers is a tougher, more careful market. So what's going on? Well, the industry's focus is shifting. It's moving from pure look what we can do demonstrations to actual early deployment. Companies are less interested in just adding more qubits and way more interested in coherence, reliability, and building systems that can actually plug into existing workflows. The demand isn't getting smaller, it's getting sharper, laser-focused. This table illustrates that new focus perfectly. You see, there's no single leader in quantum computing. The best company, the best platform, it all depends on what you're trying to do. You need enterprise cloud access? IBM's network is king. You need the absolute highest quality qubits? You're looking at Quantinuum's trapped ion systems. Tackling very specific optimization problems? D-Wave's annealers are in a league of their own. And for that deep foundational research, Google is still pushing the absolute limits. Knowing this is step 1. You have to stop thinking, I want a job in quantum, and start thinking about which of these destinations you're aiming for. So once you see how specialized the field is becoming, you can start to see how that old, generic career advice just completely falls apart. And that brings us right to Chapter 2, why that advice is probably holding you back. These right here, these are the traps that keep really smart, capable people stuck in neutral. First, there's credential obsession. This idea that just one more publication, one more certificate is going to be the magic ticket. Then there's generic upskilling, learning a bit of everything without a specific role in mind. It's like sailing without a map. There's also ignoring the fundamentals of classical software engineering. That's a huge mistake. But the biggest one? Lacking a portfolio of hands-on projects that prove you can actually build something. That's a deal breaker now. This quote from a 2026 hiring report just nails this shift perfectly. The industry isn't just hiring quantum thinkers anymore. It's hiring people who can contribute to very specific, outcome-driven programs. Can you build an algorithm for a financial model? Can you help execute a hardware roadmap? Can you actually implement post-quantum crypto? These are the kinds of questions hiring managers are asking right now. And all of this leads to something called the entry-level squeeze. You see, quantum teams are still pretty small and super specialized, which means they just don't have the luxury of carrying junior members who need months of handholding. They need people who can jump in and start delivering value fast. And those simple little circuits and basic demos that used to be impressive, well, with SDKs like Qiskit, they're so easy to create now that they just don't make you stand out anymore. The bar has been raised. Simple as that. Okay, so it's a high bar, I get it, but it is not insurmountable. The real question is, how do you get yourself over it? Well, that brings us to Chapter 3, the Strategic Career Framework. This is how we stop guessing and start being strategic. I'm about to show you one of the most powerful career planning tools you will ever see. It's called the CFQT, and it's basically a master map of the entire quantum skills landscape. It was built to create a common language for universities, for companies, for you, to define what it actually means to be skilled in quantum. And we're going to use it as our personal GPS. The whole framework is built on 3 main pillars, and it helps to picture them as a triangle. Pillar 1 is quantum concepts. This is your foundational physics, your math. Most PhD programs live right here. Pillar 2 is hardware and software engineering. This is the practical know-how to actually build the systems. And Pillar 3 is applications and strategies. That's understanding how to apply all this tech to solve real business problems. Now here's the key. A great career isn't about maxing out your skill in just one pillar. It's about building a strong, balanced profile across all 3. And inside each of those pillars, the CFQT defines your skill level on a scale from A1, which is just basic awareness, all the way up to C2, which is the ability to actually innovate and lead the entire field. So maybe your PhD gets you to a C2 in the concepts pillar, which is awesome. But your career strategy from here on out is about deliberately picking projects and jobs that build up your skills in the other 2 pillars, moving you from just being a theorist to being an engineer, an architect, or a strategist. So what does that engineering pillar look like in the real world? This is a perfect example. This is the Munich quantum software stack. Now, the key thing to see here is the layers. Over on the left, you've got high-level languages like Python, stuff you're probably familiar with. Way over on the right, you have the physical qubits themselves. The whole stack in between is where the magic happens. This compiler layer right here, for instance, it's basically a translator. It takes your abstract algorithm and turns it into the exact sequence of microwave pulses the hardware needs to understand. Knowing how these layers talk to each other, that is what separates a researcher from a true quantum engineer. Okay. Let's make this real. It's time to turn all of this theory into direct action. This is the most important part. Chapter 4, your personal action plan. This checklist, which is adapted straight from 2026 hiring trends, is your new roadmap. Number 1, deepen your technical stack. Stop being a generalist, pick a lane. 2, rewrite your entire CV around the impact you've had. And we're going to look at exactly how to do that in a second. 3, build domain awareness. Learn to speak the language of finance or pharma or whatever industry you're targeting. 4,
Work on your communication skills so you can explain these incredibly complex ideas simply. And finally, number 5, be strategic. Don't just blast out applications. Target specific companies with clear roadmaps that actually fit your skills.
Okay, so what does a portfolio that screams impact really look like? It is not just a collection of your old Jupyter notebooks from school. No, it's things like contributing to major open source libraries like Qiskit or Kamit. It's taking an algorithm, implementing it, running it on real quantum hardware, and then benchmarking the results and writing a detailed analysis of the error rates. It's building a simple tool that a chemist who's not a quantum expert can actually use. It's all about creating real value, not just writing code.
And this right here is the single most important change you can make to your CV. I'm serious. The before is so passive, worked on quantum algorithms. The after is active, it's specific, implemented and benchmarked quantum optimization algorithms for problem X, achieving result Y compared to the classical baseline. This tells a hiring manager not just what you know, but what you can do. Your CV should be full of power verbs, designed, implemented, calibrated, optimized, integrated. So, if you boil everything down, the core message is this. The quantum industry in 2026 is no longer hiring students. It is hiring builders. The demand is for applied engineering, for hybrid skills, and for a track record of demonstrable impact. The opportunity is absolutely enormous, but the price of admission is a portfolio of tangible work. Which really just leaves us with one final question. What is the one project you can start this week that moves you from being a passive learner to an active builder in the quantum ecosystem?